Hi, I am Benin Pilla and today I'll be your maths teacher, and today we'll be focusing on a topic called analytical geometry. You may ask yourself, what is analytical geometry? Then to answer that question, analytical geometry is the use of formula to analyze the length, gradient, the midpoint, equation, maybe center of a circle, equation of a circle, and certain points in their length. Then we have something called coordinates. It was taught to us in grade 10. If you remember, in grade 10, we were introduced to a Cartesian plane. What is a Cartesian plane? A Cartesian plane is these two lines. It consists of the x and the y. So when we have a Cartesian plane, we have points on the Cartesian plane which where we find the coordinates. Let's say, for example, we are given this point here. It's called point B. We have the x and the y coordinate. Those two coordinates, okay, on the Cartesian plane, these lines are positive. The coordinates of this side, this y here is positive and this x here is positive. Then we move to this line. This x is negative, this y is negative. This is a negative x and a negative y. This is a positive y. This is a negative x. Then here we have a point. We have points, as you can see. We have the x and y points. Then we can find the distance between 2 points on the Cartesian plane. Those distance, we can find them. Let's say we are given A and B. We can find the distance. We have a distance formula. It is represented by the letter D. So here we'll have the distance of AB. Here is A, here is B. The distance of AB will be given by the square root of x2 minus x1. It will depend on you whether you want to use, whether you take this as our x1 or as our x2, or you take this as our x2 or as our x1. But whatever you do, if you take this one as your x1, when we go to the y, your y coordinate here must be y2. For example, let's say here we have 4 and 3, for example, right? And here we have 2 and no, these are negative, we'll have a negative 2 and 4, negative 4. So for example, if I take this one as my x1 and this one is my x2, to find the distance of these two, I will have d is equal to the square root of x, let's say x1 minus x2 squared plus y1 minus y2 squared, right? So when substituting, I have this 4. It is the square root of, as my x1, it is 4 minus 2 all squared plus, I must again take this as my y1. I will have plus 3 minus y2, where is y2, minus into minus 4 all squared. Do you get me? Then we have the gradient. Here is our gradient. It is represented by a small m, a small letter m. So we'll have the gradient of AB, yeah, the 2 points, will be y2 minus y1 all over x2 minus x1. Or you can say it's y1 minus y2 all over x2 minus x1. Right? Then we have the midpoint. It is represented by a capital letter M. To find the midpoint, we are given this equation, this formula, not equation, a formula. We have x1 plus x2 over 2 and y1 plus y2 over 2. So if maybe you have a midpoint of a certain point, we are given, let's say we are given this, and they say here we have an M is our midpoint between this and that, right? To find, let's say we are given these coordinates, we were looking for the coordinates of B. Then I will say x is equal to x1 plus x2 all over 2, Then substituting this, I have this, let's say I have this as 2 is equal to x1 plus x2. I'll have a certain x plus a certain x, let's say it's 4 all over 2. Then you solve for x. Easy peasy. So I want us to do a certain question. I want us to solve it together. Let me increase the brightness. Here it is, that question. I'm not sure if you can see, but I'll try to draw it. I'm not good at drawing. I'll try to draw it on the board for us to see. Okay, so here is our diagram. It is said that ABCD is a quadrilateral with vertices A. Here it is 2 and 5. B is minus 3 and 10. C is minus 4 and 3, and D 1 and minus 2. So our first question, it asks us to calculate the length of AC, and they say leave your answer in the simplest set form. When they say the length of AC, when they talk about length, they are talking about the distance. So here is our AC. We have point A is 2 and 5, and C is minus 4 and 3. So we must calculate the distance of AC. So we'll have D of AC is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Then from here we can substitute the values, the coordinates. X2, I'll take this as my 2 and this as my 1. I have minus 4 minus 2 squared plus y2, I have 3 minus 5 squared, right? So from here we can just plug. Here I'll have minus 8 squared minus 6 squared plus minus 2 squared, all in the root sign. Then I have calculating, punching it on a calculator, I found the square root of 40. So since they instructed us to leave our answer in the simplest set form, we are going to have our final answer will be 2 the square root of 10. Am I right? Then you get your 2 marks. Then the next question, it says determine the coordinates of M, the midpoint of AC. They are directing you. The coordinates of M, the midpoint of A and C. We are still going to use the very same coordinates. So I'll have M of AC. The coordinates of M of AC. I'm going to have X is equal to X1 plus X2 all over 2, and Y is equal to Y1 plus Y2 all over 2. Am I right? Then substituting these values, X I will have 2. Okay, let me do it like, let's say this is our second, this is our first. Yes, I'll have 2 plus minus 4 all over 2, which will give us 2 minus 4 is 2 plus minus, what am I? Yes, 2 plus minus 4 will give us negative 2, right? I'll have negative 2 all over 2, which will give me negative 1. So here we found our M, our X coordinate for M. Then we move to the Y coordinate. I will have, which one is my 1? Is this one. I have 5 plus 3 all over 2 is equal to 5 plus 3 is 8 over 2 is equal to 4. So our M coordinates, these coordinates will be, what is our X? Minus 1 and 4. We calculated it. Then moving to our third question, it says show that BD and AC bisect each other perpendicularly. BD and AC. I must first first things first, I must look. I get they are saying BD and AC. So I have the midpoint of BD. I must look for the midpoint of AC, right? So the midpoint of AC, using this formula, these formulas, the midpoint of AC of BD, not AC as kids, of BD, I found it to be -1 and 4. You can use this formula to find it. We'll get -1 and 4. Then from there, since I have their midpoint, I must calculate the gradient of BD and the gradient of AC. So already calculated the gradient of AC in the first question. Now I must calculate the gradient of BD. So M of BD is equal to y2 minus y1 all over x2 minus x1. B, coordinates of B is -3 and 10. The coordinates of D is 1 and -2. Am I right? Yes. Then the gradient, they say this is our 2, this is our first. Then the gradient, I will have y2 -2 minus 10 all over 1 minus into -3. I will have -2 minus 10 is equal to what? -2 minus 10 is -12 all over 1 minus -1 plus 3. It's 4. Am I right? Yes, I'm right. Okay, let's confirm it on the calculator. I'll have -2 minus 10 all over 1 minus into -3. Yes, -12 is equal to -3. I have the gradient of BDS -3. Then I must look for the gradient of AC. I must look for the gradient of AC is equal to y2 minus y1 all over x2 minus x1. A, what's our A coordinate? Where it is A is 2 and 5 and C is -4 and 3. So this is our 1, this is our 2. We'll have 3 minus 5 all over. Okay, we'll have 3 minus 5, then x, remove the x, it's -4 minus 2 is equal to 3 minus 5 minus 4 minus 2. 3 minus 5 is -2 all over -4 minus 2 is -6 is equal to 1 over 3. Then since we found the gradient of BD, yes, the gradient of BD was -3. We're going to multiply these two gradients to see if they give us -1, then that means the lines bisect each other perpendicular. So let's calculate and see. M of AC multiplied by M of BD is equal to M of AC is 1 over 3 multiplied by -3. Then -3 minus cancel, we are left with -1. So we can therefore conclude for AC and BD bisect each other perpendicularly. Am I right? Then moving to our fourth question, they say we must calculate the area of triangle ABC. How are we going to tackle this one? The area of triangle ABC. We have the base, we don't have the height. So we must look for the distance of BM. So D of BM is equal to, the distance of BM is equal to the square root of x1 minus x2 squared plus y1 minus y2 all squared. Then B is -3 and 2, -3 and 10. M is -1 and 4. So substituting here, this is our 1, this is our 2. We'll have x2, what is our x2? Minus 1 minus into minus 3 all squared plus y is 4 minus 10 squared. Then I found it to be the square root of 40. You can check if you want to check to avoid making errors, but it's the square root of 40. Then since we found we have the height, so calculated the distance of AC on our first question. So we'll have area of triangle ABC is equal to half base times height is equal to, which is our base it's AC, what is our height is BM. Then we'll have half. We found the distance of AC to be the square root of 40, the one on the first question. We found it to be the square root of 40 multiplied by the square root of 40, this one. Then I found it to be, plug it in the calculator, you'll find that the answer gives us 20 square units. Then moving to our last question, it says determine the equation of DC. They want the equation of this line. So how are we going to tackle it? How are we going to tackle the question? We must first things first, we must look for the gradient of DC. I get this equation, we will have it as y minus y1 is equal to m into x minus x1. Our equation should be in this form. So we don't have y1, we don't have x1. Okay, we have y1 and x1. We don't have y, we don't have x, we don't have the gradient. So we must be left with only these two. So we are going to say the gradient of DC is equal to y2 minus y1 all over x2 minus x1, right? Then the coordinate is 1 and minus 2. Always try to, when you're solving a certain question, try to write the coordinates down to avoid making mistakes. Like maybe you substitute the coordinates of A by mistake. It's not it's you making a mistake. Mistakes happen, right? So try to write the coordinates down so that you know that you're on the right track. Because here you can see what is this line, then by mistake you write the coordinate, you use the A coordinate by mistake. Mistakes happens, right? So substituting, this is our 1, this is our 2, we'll say 3 minus into minus 2 all over minus 4 minus 1. We find 3 minus into minus 2 is 3 plus 2. 3 plus 2 is minus 3 plus 2 is 5, not minus. You see I'm making mistakes. Minus 4 minus 1 is minus 5. So the gradient is minus 1. Then we go back to this equation. Am I right? We go back to this equation. We'll have y minus y1 is equal to m into x minus x1. Then you see these two coordinates, this one and this one. You're going to choose a point from these two. Am I right? So choosing a point, let's say I choose point C, then we'll have y minus point C is minus 4. No, you see I'm making a mistake. It's 3. Y minus 3 is equal to m. We calculated it here with this minus 1 into x minus 4. Am I right? Now we'll have y minus 3 is equal to minus 1 into x plus 4. Multiplied by negative, we are going to have minus x minus 4. Move the 3 to the other side. We'll have y is equal to minus x minus 4 plus 3. It changes the sign when it gets to the other side. Am I right? Then our equation will be y is equal to minus x minus 1. Emma, are we still together? So we have come to the end of our lesson for today. See you guys next time. Bye.